Alright, so this, the proof of concept. So first off we have the import Pygame as PG, that just makes it shorter, so I don't have to type in Pygame all the time, it just makes it easier. Here we have the math vector 2, it allows me to use 2D graphical calculations, so I can have X and Y from the screen. If I start up the application, I'll probably leave this running as well. There we go. As you can see here, it just allows me to calculate where on the screen certain objects are. That just makes it easier. Next we have the class entity, which is a sprite. It essentially is the locomotive that's moving about, and has all of this in order to it has all this to update itself. Here we have the when it initiates, so it will super the init, and essentially this is where it draws. Well, how big it draws. This is the color it is. This is the rectangle it is. This is the velocity of it. As you can see, it's in vector 2. That means it will calculate the velocity in coordinates. So if we pull this back up, as you can see, it's moving along at a straight line. The way the velocity works is it calculates how far it has to move from one space to the other, and in how short of a distance. So if the speed was 1, it currently is 3, it would be 1 pixel at a time. However, this is jumping about 3 pixels per time. As I've just said, the max speed, of course, is how far it goes, how many pixels it jumps. The position is the position of the locomotive. The waypoints is the dozens of waypoints we have, and I can add multiple. It will just count them all up. I don't have to put in any numbers. I just put in a waypoint, and it draws it directly onto the screen. I'll get to that later. We have the index, so it counts out many waypoints. That means I don't actually have to draw every individual waypoint on its own. The target, so that just makes it easier to write, because it's essentially just the next waypoint it goes to. Yeah, and it just means I don't have to type out all of this. The target radius is the radius around, in pixels, the locomotive to its destination. Essentially, in 50 pixels, it will detect that there is a new waypoint coming up, and it will slow itself down automatically, just nicely glides into the station, like a normal train. Here we have what happens when the entity updates. So it will have a vector pointing from itself to the target. Essentially, the heading is the target minus the position. So say we got the target at 400, 500, like right here, and the locomotive is at 200, 500. If we pull this up, it will just put the heading to where its destination is and take away its position, meaning that's the heading it has to travel at in order to get to the target. The next thing is the distance is the heading's length. So essentially, the distance is heading and how many that is. Heading normalize IP, this sets the heading to 1. So instead of making it so that it just jumps about halfway, it essentially means that it increments by 1 every pixel, instead of just jumping 200. That's what distance does as well. It just makes it the distance between the target and the locomotive, instead of calculating it on the entire screen on where the position is. If distance is greater than 2, well, no, that's less than 2, then we are closer than 2 pixels. And that means that it's going to just increment to the next target. I misspelled that wrong. I'm just gonna, yeah, let's just leave it like that. So essentially, if it reaches the end of the waypoints, it will just go back to 0. I can pull this one up now. So as you can see, I've got this little debug menu, just counting down the numbers it travels at. So once it reaches 0, it will go to 1. Once it goes to 1, it goes to 2. Once it goes to 3, it goes to 0. Because it's reached the end of its length. That's what this calculation here does. The self waypoint index. So the waypoint index, the thing that counts this, it adds it by 1, and then if it's reached the length, or if it can't go over the length, actually, it will just go straight back to 0. That's it. And then it will continue the process over and over again. It means I don't have a second line of code in order to calculate, if we reach certain number waypoints, then we just go back. It does that all in one line of code. Much easier. Self.target equals self.waypoints, self waypoint index. It updates the target, just makes it easier than texting it like self.waypoints, waypoint index. It just makes it much simpler, shorter, nicer. Here is the debug. That's fine. Just prints out the waypoint index paired with the target, so I know that it is going to the right target and going up normally every time. Here we have the if distance is closer than or within range of the radius, so if it's within 50 pixels, it will slow down. So essentially the heading times the distance divided, heading times, in brackets, the distance divided by self.target radius times self.maximum speed. So if the distance is within self-target radius, and depending on the max speed the train has, then it will times by the heading and travel slower in that direction. As you can see here, when it comes to the station, it will just travel a bit slower. And that does happen incrementally as well, so it won't just go straight to a certain speed, it will just slow down incrementally. It's lovely. Otherwise, just go full maximum overdrive and just go the max speed. As you can see here, it goes at free maximum speed, so it just doesn't zoom along. But when it's traveling from here to here, which is 3, 2, 1, then it just travels all as fastest as it can, and then heads back. If I want the train to move slower at a larger radius, I can increase the radius, and if I want it to move a bit faster, then I can also increase the max speed. However, this is good enough for now. It doesn't incrementally drive forward at slowly from the station, which I may add, but I also might not. It depends. It would be more realistic to add it, but at the moment I'm trying to focus on the rest, such as the switching system, for the entire thing, because that'll be an interesting thing to do. Here we have the self.pels plus equals self.velocity, which makes a new position depending on how fast it goes, as you can see here. Essentially meaning that once this travels from its position plus the velocity, it will go at a further position depending on the velocity, or a shorter distance depending on how fast it's going. Anyways, self-explanatory. Self.rectangle center is the new position. That just means that the position isn't updated by the center instead of like the end, so it just stops at the center of the rectangle. Here we have the main. When the entire program starts running, it will play the initialization, then the main, and then quit. However, there is no stopping at the moment, apart from when you close down the window with the X button at the top right. Main. So we have, of course, the usual display. Then we have the clock. The clock is very useful, counts the time. But in this case, it counts how many ticks run every time. At the bottom, we have, for every 60 seconds, every 60 ticks, correction, a millisecond passes, meaning that every 60 ticks, it will move the locomotive forward, or move it back, depending on how it works. It will update every 60 ticks. Here we have the waypoints, so if I close down this, as you can see already I have 4 waypoints, and I can add one at the very end if I do this. So let's have it go up from 800, yeah. Alright, I've not had to change anything, and it's already added one more on, so of course I'd have to draw that, wouldn't I? No. The entire thing does that for me. I have drawn that completely going off the entire screen. I am so sorry, but it's right there. And there goes a train. I am also trying to figure out how to get that to how to get the train to rotate from where it is. But once I figure that out, then I can work on curvature. But for now it's fine. Doesn't really need rotation. So here it will print all of the entities in class entity, or everything in entity, onto the screen. So for now it'll print all sprites as sprite group entity, and one at 0, 500, and it will follow waypoints. When it's done, it will update this to true. The Boolean value is just to tell me that the entire thing is done. I will probably make that print as well, just so I know when the application is finished. And so while not done, it will, for every event, so for literally everything that happens, every tick, every change in code, everything, it will check if I've pressed quit, if I press the X in the top right. And when I do, it says that we're done here, and just changes that to done. And just completely finishes the thing, doesn't run it in the background, absolutely fine. Then, during this while loop, it will update the sprites. So, all sprites, it will update them. And then it will fill the screen with an empty void, of course, screen fill. Then draw the sprites on screen, along with drawing the lines between the waypoints. And for every point in a waypoint, it will draw a little green square to show the waypoint. So we've got the positioning, well, we've got the screen, the surface we'll use, we've got the coloring, that's it, the coloring. The point in the waypoints, so every single one of these 2 values, and then the size of them, which is 4 pixels by 4 pixels. Then it will flip the display, meaning it pretty much updates everything on screen, and will repeat every 60 ticks. Because if I set this to 1, it would be going much faster than every second, and would be a pain in the ass to just fix. Because I'd have to make everything a bit slower, everything a float value, so I'm running it at 60 ticks so that it runs every millisecond. Makes it every bit better. And of course I've talked you through the if name is main, then the main just runs after the initialization, and it quits after main is done. However, main is never finished until done is true. So, yeah. That's all fun and games. That's everything so far. This is the first part of my design done, pretty much. Not even done. Requirements, that's it. And yeah, thank you. I will now go and consider drinking myself to sleep. Yeah, thank you. Good night.